Hi everyone, part 3, probing the structure of matter. Okay, so this is where highly theoretical becomes really highly theoretical. Okay, but that's all right. Particle accelerators. There are some pretty strong forces holding an atom together. So to overcome these forces requires a tremendous amount of energy. Particle accelerators use magnetic and electric fields within a vacuum chamber to speed up charged particles, thereby increasing the kinetic energy of these particles. Okay, so typical speeds are, a tenth the speed of light. Okay, like this, the closer and closer you get to light, the more and more energy you need. But these things are, wow, like, remember light is 3.00 times 10 to the 8th. So these things accelerate particles like 3.00 times 10 to the 7th. Okay, so very, very, very fast. Okay, so once these particles have sufficient energy, they are smashed into other charged particles. Okay, just to see what happens or to see what's produced. Okay, in order to obtain these speeds, very large distances are required. Accelerators then are typically circular to save space, as the particles that are smashed are released in opposite directions. Okay, the Large Hadron Collider has a radius of about 4.3 kilometers. Okay, a radius of 4.3. So that means the whole circle would have a diameter, right, of 8.6 kilometers. Okay, and it's about 100 meters underground. Okay, these things are absolutely huge. And again, circular so that the particles can gain enough speed each loop they go. Okay, one particle goes one way, the other particle goes the other, and of course then they smash together sometime in the middle once their optimum speed has been achieved. Okay, so let's talk about the subatomic zoo. Okay, once the multitude of other, okay, so not protons, neutrons, and electrons, so once the multitude of other particles were discovered, and, of course, to assist with the discovery of more, classifying them became an important part of the job. Now remember, when they started organizing the periodic table, okay, they found holes in the periodic table and were able to predict properties of elements that they couldn't see yet or didn't have yet. So the idea here is they wanted to classify all these new particles so that they could see if there were similar patterns to the periodic table. Okay, so in the subatomic zoo, all the subatomic particles, there are only two families. Okay, so the two families are leptons and hadrons. Okay, so leptons are particles that do not interact by the strong nuclear force. Okay, they have very small or much smaller diameters, and there's only 6 of them. There's only 6 leptons plus each of their antiparticles. Remember, every particle has an antiparticle. So that means that there are 12 leptons. Okay? Well, 6 leptons, 6 antileptons. Okay? So, anyways, very, very small, do not interact by the strong nuclear force. Hadrons, on the other hand, are particles which do interact by the strong nuclear force. Remember, that's what holds protons and neutrons together in the nucleus, that force. Okay? Very, very strong force. Okay? These have much larger diameters than the leptons. Remember, these are still, so incredibly small, but that's okay. They're just large in comparison. Okay? And the hadrons are broken down into 2 subgroups called mesons and baryons. Okay? So, mesons and baryons are separated due to their spin. Okay? If a particle has a half-integer spin, it's called a fermion. Okay? So these guys, fermions, are half-integer spins. So a half spin. So that would be like a half, 1.5, 2.5. You get the idea. Okay? So all leptons are fermions, so they all have half spins. Okay? And the hadrons, the baryon parts of those, okay, they have the half spins as well. Okay? Now, bosons, on the other hand, okay, they have full integer spins. So, full spin. Okay, so that's like a 1, 2, 3, 4 kind of thing. Okay, so bosons have the full spin. Okay, leptons can't be bosons because all leptons are fermions. All leptons have half spins. Okay, So the mesons, okay, they are full spin hadrons. Okay, so remember, mesons and baryons are both hadrons. Okay, mesons have the full spins. Now, all the mediating particles, okay, for those forces we saw on the table last section, all mediating particles are bosons. They all have full integer spins. Okay, now you should know the difference between them, but not memorize which particle belongs to each group. Okay, as seen in the next table. Bum, bum, bum. Okay, so we have leptons, mesons, and baryons. Okay, so you'll remember leptons, those are the fermions. Fermions, as in a half integer spin. Okay, baryons were also fermions with a half spin. Okay, mesons were the bosons, okay, with the full spin. Oops. That's all right, full spin. Anyways, not a big deal. Now remember the whole point, okay? So leptons, okay, those are the no nuclear force. No strong nuclear force. Nuclear force. Okay, whereas mesons and baryons, these ones have strong nuclear force. Strong nuclear force. Okay, awesome. So remember leptons, there's only 6 of them. Okay, they are the electron and the electron neutrino, the muon neutrino, and the tauon neutrino. Okay, so remember those 6 particles, these are the leptons, and of course they have their antiparticles. So remember, an antiparticle just has that line on top. Okay, so a mu with the line on top is an antimuon. Okay, now an antimuon, of course, would be positive. An anti-electron would also be positive. Okay, you guys get the idea. Okay, a tauon, of course, would be a T with a line on top. Okay, all good. Okay, so then these bosons, these full spin ones, so pions, kauons, scions, and upsilons. Okay, and then of course the baryons. Okay, these are the more familiar ones. They're protons and neutrons. Okay, so a proton and a neutron, those are baryons. Okay, and they have half integer spins. All right, great. Okay, good. Again, super highly theoretical. Okay, I want you to practice this stuff by doing section 17.3, starting on page 844, 1, 2, 4, 5, and 7, please. Thanks so much. See you next section.